Hello, dear listeners. This is a small interruption on your way to enjoy the podcast with an announcement that should help you to enjoy it even more. We're launching an experiment on Discord to have a call-in style follow-up to the episode. You'll be able to hop into the call as well as text questions and responses. Our guest has kindly agreed to be part of the experiment. We'll add details to the show notes and follow mine, VJ's, or the @Defen Podcast Twitter account for more details. Okay, let the fun begin.
Shoi fihi he lahoi Defen, which is to say hello and welcome to Defen.
But who constructed this? Sorry, because I just pressed record, so I think we need to step back a little, or rewind a little bit. So what is the language name again?
So I speak two languages, English obviously because that's what we're talking in, and Lojban, which is a constructed language based around predicate logic.
Lojban.
The existence of the language, like who created it, is a little bit fuzzy because the original version is called Loglan, and Lojban exists as a result of a split because of copyright. Where the original creator of Loglan
so somebody
tried to copyright the language, and it didn't go over well for him. But by the time all the court proceedings were over, there was already this fork.
Oh wow!
So yeah,
language forks are not unheard of, but that's
yeah. So the author of Loglan, I believe, was John Cohen. And the idea was to test the Sapir-Whorf hypothesis, which is the theory or hypothesis that the language that you speak affects what kinds of thoughts you're able to have.
Yes.
And so the idea was, if we have a more logical language, do people speak more logically? Like, do they think more logically as a result of the language having those primitives built in? And it was a resounding failure of an experiment, not because we weren't able to actually test anything, but because we didn't have enough people to have a reasonable
So you mean none of the logical people learned this language?
Oh yeah, there's a ton of people who are interested academically in the language and never learned it, including an entire committee around trying to change the language. Almost none of them can speak it.
Like C++ committee.
Yeah, pretty much. It's like C++ committee. They all write the standard, but they don't use it for their work. So there's a community of people who do actually speak the language. Like I have a number of friends that I don't share a language with them besides Lojban, and we're able to communicate just fine. So it's able to work. It just needed a few tweaks for usability past what was originally in there. In order to.
But is it also like a written language? Like there is a structured grammar and everything, and
absolutely.
Okay.
The entire thing, with the exception of a couple minor pieces that are used for conversation flow, can be parsed with a peg grammar. So, and it is entirely syntactically unambiguous.
Okay.
Which means sentences like, I saw a man on a mountain with a telescope.
Yeah.
It's ambiguous if the man had a telescope or if I used a telescope to see him.
Yeah.
You cannot construct a sentence like that in Lojban. It cannot exist and be grammatical because it is a result of something called polysemy, which is a single word having multiple meanings. And that creates an ambiguous grammatical structure and an ambiguous semantic structure, and it just can't exist.
Okay.
So there are no synonyms in the language then?
Oh, there's plenty of synonyms, but there are no homonyms.
Right.
Or homophones.
Okay. All right. Okay.
Yeah.
And is there a standard library?
Yes, and a surprising amount of stuff that deals with quantum physics.
There is a sigh, Lojban.
Yep. But yeah, so that's
pretty cool. I mean, is it something that you can learn online, or is it? I'm assuming there will be a lot of online resources for this one, right?
Yeah, it's a lot of online resources. There's a website, lojban.io or lojban.io.
Oh, .io means it's pretty recent.
It's pretty recent and it's quite good. It's got like interactive grammar exercises, translation exercises. It's like Duolingo but tiny.
Yeah. Okay.
So maybe the obvious question,
cool.
though, Joshua, is like how did you get into this language? What made you what motivated you to learn it? Because I've never heard of it, and it's it's quite an unusual thing.
Why
even
do you
for
have so much free
geeks,
time? That is the question, I guess.
Well, why do I have so much free time? That's
no, that's assuming that you have too much free time to use the language to learn the language.
How
you made time for it?
I think I had about 3 months between the graduating college and getting my job that I was just at home with my parents because they wanted me back for a while.
Yeah.
And I picked up the language then because I heard some music in it and it sounded really cool. And then I read up on kind of the promises that the language makes about syntactic unambiguity. And one of the other ones is audiovisual isomorphism, which is to say it is identical written and spoken.
Yeah.
So a lot of people will look at it and like be confused by punctuation in it because you'll see periods in weird places. And like no quotation marks or anything else like that. But that's because it's entirely through words. Like in order to, it would be like speaking quotation marks and periods and other punctuation marks. And they're a part of the spoken language. So there's like these other pieces, and it has also one of the best methods for expressing emotion out of any language that I've seen. Because before Lojban, I studied like 4 languages, and never actually was able to speak any of them, despite studying each of them for multiple years. And it took me until I was learning Lojban to realize I was a language nerd. But okay.
But having
well, you definitely got confirmation bias on that one.
Yeah.
But if you don't have homonyms, then there is a big class of jokes not possible. There is certain type of humor is not possible anymore in that language, right?
Certain types of puns.
So you can't make puns, and
true.
you can't make
we do
double
make
meaning
puns
jokes
all the time. Actually, yeah, there's all kinds of jokes that do get made that are wordplay, including those sorts of things, but they're different from the ones in English.
Yeah. So because you can't use the same word to mean 2 different things, because that is basically the butt of the joke in some times. And
well,
like, he said there are synonyms.
Yeah,
synonyms.
There are
but
synonyms.
if you use the different, if you use a word in one context, and like there is this Zafrank video, on YouTube. The guy makes super awesome comedy, not comedy, but natural history things, and he always says, but John, and then but like he uses but to sound like but, butt, but not but. So that kind of things will not possible, right? Using the same word to make weird jokes.
Or like the classic dad joke, I'm hungry, hi hungry, I'm dad, isn't possible. Like there's a lot of jokes like that aren't possible in Lojban, and that's
I think
true.
If dad jokes are not possible,
but
that's a good
thing. You're not losing much. Exactly.
You're stopping the shit getting into it, so that's pretty good.
Is there a
Reddit
like
community? A compiler that's automatically telling you that bad humor is banned from this language?
Exactly.
Not yet, but there might be. People have been working on ways to translate it to Word2Vec and other stuff like that in order to try and get it in other translation engines, and other similar work. There's like 4 different programming languages that have been started and been at least specified. I don't think any of them have like a complete runtime yet that are written in the language. I've started one of them. It's a Prolog-like language.
Nice.
This is amazing. This is absolutely amazing.
Yeah. I think this is the first Lojban edition. I'm not even sure if I'm pronouncing it correctly anymore.
Lojban? Yeah, you're pronouncing it much better than
how do you spell
Lojban? Lojban.
Okay. That's why you
Is it
can
B or
say my
P?
name.
Sorry.
Sorry, what was that?
Is it B or P?
B.
Okay.
Yes.
Lojban. Okay.
Lojban. Yes.
Yeah. Sounds like Autobahn in Germany, like a highway road or something. Nice. But where did the word come from? That has meaning in the same language? Is it like a recursive thing?
So the vocabulary in the language is entirely, or the core vocabulary, like root words, are generated by averaging the transcribed by English people sounds of the 6 most common at the time of creation spoken languages around the world. That included English, Mandarin, Arabic, I believe Hindi,
Spanish.
and
Spanish and Hindi, maybe? Yeah.
and one other one.
Okay.
Russian, I think Russian.
Hmm.
But yeah, so there was 6 languages transcribed by people who speak mostly English, so not perfect, but
I mean,
and
you
then
said mostly
averaged.
spoken. Then I assumed like top 5 is going to be some 5 Indian languages, given that we are like 1 billion, more than 1 billion people, and it's just Chinese and different types of Chinese languages.
Yeah, it was certainly not the most accurate in terms of actually weighting by population.
Yeah,
I wouldn't give it credit for that, but it tried.
Okay. But
So
nice.
Lojban as a word is a compound word from logji, which means logic, and bangu, which is for language.
Ah, okay.
So Lojban is just a compound word of those two.
Wow. This is the first time ever I think we are having a guest who is speaking a decent language,
Well, I think the obvious question is there an Emacs mode for it? Because
yes, actually, there is.
Oh my god!
There are 2 Emacs modes for it. One of them is a dictionary search. The other one is syntax highlighting for particles and verbs.
Well, that means it's a legit language. There is no question around it. Then, if you have said no, then this is bullshit. I mean, this is not real. This is not real, and this is useless. And then immediately you said Emacs. Okay, this is real and it is very useful.
And
everybody should learn it.
I expect you to be speaking it in the next episode, PJ.
Next episode will completely in Lojban. And that means our audience is going to go from 2 to 1. It's just going to be Joshua.
I mean, I can speak a sample if you want, but it's always hard coming up with something to say on the spot.
Yeah. But
well, you could say, something along the lines of, I like Clojure because, and you could just give the first top reason for that in Lojban.
Iminal shi la Clojure ki hu lo duhu la Clojure shu kakne lunu shikre lo he sido vaho lunu dahido pilno lo sampu kupoho.
Yeah, I'll translate that one. I like Clojure because it has an Emacs mode.
Yes.
That's it.
Yeah, the actual translation is more or less, I like Clojure because it allows me to express solutions to problems in using simple stuff. So
wow. That took a pretty long time to say that. Maybe it's because it's very specific.
It's less dense than English. It's about the same level of density as Japanese. Excuse the cat sitting on my shoulder.
Yes, for the people who are listening but not able to see, there is a beautiful cat on the shoulder speaking in Lojban to Joshua in his ear.
He's like on a little route around your room, isn't he? He's going down, then he's going around, then he's going back up your shoulder, he's going down again. It's quite fun to watch,
Yeah, she likes sitting on the back of my chair and then just headbutting me. I don't know why, but that's what she likes doing.
Nice. But I think speaking of the specificity of the languages, I remember reading, maybe I mentioned this on the podcast some time ago, I'm not sure, because in English there is also this as you said, like, how language affects our thinking. Like in English, you have this is, P forms, like is, was, and all this shit. And And then they say that you conflate two different things, like asserting facts versus expressing something. So we just keep using the B
Absolutely.
forms to get away with shit without actually mentioning what you're supposed to say.
Yep.
Like, sun rises and sun is rising is a fact versus,
Mhm.
oh, it's hot, like, so instead of saying I feel it is hot or something. So there is
Yeah.
a E prime mode, obviously, in Emacs to use, and there is language called E prime, which disallows or which doesn't allow to use any of the B forms anymore.
Hmm.
So essentially, you cannot say to be or not to be in E prime anymore. So there is this. I think there is a guy who actually wrote a novel and like
So
books
English without the
without this.
copula.
Yeah. So
Okay.
without the B forms at all, like is, was, or
Mhm.
are, you cannot say that. So I
Yeah,
cannot
there's
just
like
say, the water is good. I cannot say that anymore. I can only say, I think I feel. No, I don't even fucking
I
know
enjoy
how to say that
drinking the
anymore.
water, maybe.
Yeah, exactly. I enjoy. Yeah, there must always be like some subject and
Mhm.
object, and then there is something linking that one. There is a correlation must be there. Otherwise,
Sure.
because it might be good for me, it might not be universally good. So you cannot
Mhm.
conflate universal truth with this one. So,
Or I
but yeah,
enjoy drinking this glass of water, more
Right.
exactly.
specifically.
Yeah, at this moment.
Mhm.
So time and space.
It's fucking exhausting to read that shit, though.
Yeah, I could see that.
It's like, oh my God, please, I get it. Yeah, can we just shorten it now?
But I think it really forces you to learn more verbs in the language, because otherwise you keep just putting ease everywhere. You don't need to think about
Mhm.
what you're gonna say actually. So which is pretty interesting. Anyway,
Yeah.
but yeah, so I think it's a good time after 15 minutes to welcome you to the podcast.
Yes.
Thanks.
Welcome to
Yeah.
Defen, episode number, I think this is 81. Most probably our last episode for this year. Fucking hell.
Excuse me.
Okay.
So I tried to mute the sound there, but we Miss Whitewell had to fix that one in post. Right in the middle of your introduction. Let's try that one again.
Okay. I'm going to say this again. Okay, this time don't sneeze. Don't cough. Welcome to Devon episode
Okay, fuck it. Leave it in. Come on. Let's. We've fucked up so many times on this show. Come on, one more time is it going to hurt?
Fair enough. I think after 7 years, people are like, well, this is what we expect from this shit show anyway.
I mean,
on that happy note, welcome to the Defen podcast, the Defen podcast, Joshua. So, I think it's a good time to give us a bit of introduction about yourself in English.
Sure.
I'm pretty sure there's like hordes and hordes of people speaking Lojban listening to the podcast, but I'm missing at least there are 2 more people who can only speak English than those people. And also,
Right.
tell us about your programming journey as well. Like, how did you end up in Clojure?
Yeah. So it's I don't know if I would say particularly interesting, but it's been a bit of a long journey. I started programming when I was 9 years old after my brother discarded a book on game programming because he found it too difficult. And after going through it for like 3 months, and I picked it up and went through it for a weekend and came back home the next day from the library with a stack of like 12 ridiculous computer science tomes that I had absolutely no business trying to read. And my dad took me aside and was like, oh, "Here, we'll get you something better to start with." And he got me a Java book for like Java 1.4 or something, even though I think like Java 7 was out by then.
When you were 9, holy shit, you're a young guy. Okay.
Yeah, I'm 23 now. Yeah, 23.
Oh man. Okay.
Good.
Yeah.
So
okay.
I spent
That makes sense.
I spent like 8 years or something just working with Java and doing just like simple GUI applications and other things like that, getting comfortable with that language. I did like some machine learning with it. I did
Nice.
like
Did you do
automation.
the Minecraft plugins or anything like that?
I did actually for a little while, and
Mm.
published a couple of them. None of them got famous or anything, but I did make a couple. I did like some financial automation software for myself, like those kinds of things. And then I got to the AP Computer Science. I was homeschooled, so I didn't like have this through a school, but I had an educator who was available to me, and he used Clojure, not for the AP Computer Science class, but on his own time. And he showed me a circuit simulator that he made using Seesaw. And at the time, it just seemed like a weird language that I wasn't sure why you would pick it over Java.
Yeah.
But it kind of stuck in the back of my head, the things that he was telling me about functional programming and the style that could help make programs more effectively. And then between then and college, I started branching out and trying a whole bunch of other different programming languages. By the time I graduated college, I think I'd used about 30. And I went to college for game development, so like programming game engines.
Yeah.
Right.
Like Unity or Unreal are game engines. They have hundreds of developers and millions of man hours into them, but it's the same thing. And that's what I went to school for. And in like some of the first courses of programming that I was basically dramatically overqualified to actually be taking the class. So I just had a lot of free time beyond the assignments. I started to build a game engine, and in a very, very object-oriented style. And by the end of like the first month that I had like a menu system and a way to swap out between like different states, like if you're in a menu versus in game loading systems and stuff like that. But it was a complete rat's nest because of the fact that it was object oriented. And that might sound a little bit odd to people who still like object oriented programming, although I don't imagine that there's many of them listening to this podcast.
I don't think so.
And
leave the podcast
now.
if you like that.
Yeah, so
you're not welcome here.
But that kind of got me to think about what my APCS teacher had been telling me, and it got me to try Clojure again. And so I started learning Clojure with Clojure from the Brave and True. And for the next like 2 months, I did all of my assignments in C++, like we were instructed to. But I also did them separately in Clojure, and even submitted a couple of them to my teacher, and they thought it was pretty cool that I was able to get them working as well. And that really made everything kind of click for me. And so by the end of the degree program, I had ditched C++ and was writing everything in C. Because I wanted to avoid object-oriented programming that much. And I made a game engine that was fairly capable, with like a Lua scripting engine and some other stuff, that was entirely without object-oriented programming. And that really got the ball rolling for me. And after college, I started diving into Clojure more and more and more. And at this point, I've released 3, I would consider relatively major libraries for the Clojure community. Some of them see more usage than others. And those are Clojure, which is a library for connecting to the Discord chat platform and providing bot applications for that platform using Clojure. And all that's like core.async. There's ridiculous machinery behind the scenes in order to transparently handle sharding, some stuff to allow you to orchestrate splitting something across multiple boxes and coordinating between them, and the rate limiting stuff that Discord does is utter nonsense. And as a result, I finally got a really good use case for agents in Clojure.
Mm-hmm.
The second one that I made,
that's not something people still use that much, right? Agents are like the one of the
yeah. So I have found that atoms are the thing that everybody uses like all the time. And that's fair. They're useful most of the time. Most of the time they work pretty well. I have, at this point, in the last 5 years that I've been using Clojure as kind of like a primary language, found good usage for every single one of the Clojure core primitives for everything from delay to agents, refs, all of those. I've found good usage for them, but it is dominated by atoms. That's true.
Yeah. I think if you see the original STM stuff when it was announced, like agents and refs and wars,
people thought refs were going to be really big.
Exactly, that thing. I think everything converged to atoms. So then I think the rest of the stuff is now handled by other frameworks mostly. So you don't.
But interesting point about that is that nowadays people are moving to volatile.
No.
Yeah, I use volatile a ton, but only in things that I actually know the thread constrained environment. I don't like sharing them across threads, even though you technically can.
Yeah.
So for refs in particular, I found actually like only 2 instances that ended up being useful, and it's because one of them was connected to working with development time tooling, where one of the references did not need to be changed almost ever, but the other one needed to be changed at runtime fairly frequently. So it didn't make sense to put it all in an atom, because then I could cause contention at development time if I was debugging an environment. When instead I could just have them be refs and it would end up working out better.
So this is all the Discord library.
Yeah, wow. The refs actually is used professionally. I work at Iris TV, which is a mostly Clojure shop, and we do stuff in the ad tech industry for video context. And that's where I've used refs. The other place I've used refs is in farolero, which I'll probably get to a little bit later. But yeah, for Clojure, agents and core async all over the place. They're the main concurrency primitives that I'm using.
Okay. And what are the other libraries? Because you mentioned around 4 of them right now already? Or?
Yes. I guess, 3 or 4 of them. One of them is a build library that I almost kind of don't count. So there's Clojure, there's farolero, which is a mostly faithful port of Common Lisp conditions and restarts to Clojure.
Okay.
And I did this because every single condition system library that I've seen in Clojure is terrible in one way or another. I don't really mean that as a diss at the people who made them, but it's just that all of them solved a subset of the problem that conditions and restarts was designed to solve. And maybe it's none of them are really compatible with each other.
Yeah, it's better to explain what is the awesome stuff about conditions restarts, right? Because in Clojure world, in Java world, we're used to these exceptions so much. I think in Common Lisp there is like a very elegant solution there, right? So maybe it's better to explain that one, so people who are not familiar with it.
For people who don't know, conditions and restarts is a system to decouple unwinding from error handling and error recovery. So there's 3 stages when you're dealing with conditions and restarts, as opposed to in exceptions, it's basically error detection and error recovery. Error detection happens when the error happens, you throw an exception. Error recovery happens somewhere up on the call stack. But you lose all of the stack context, your local variables, etc., as you throw up the call stack. You lose all that context. The way conditions and restarts happen is you have your error detection. When you detect an error, you signal a condition, which basically asks further up the call stack to say, hey, does anybody have something that handles a number format error? Like, if anybody handles a number format error, then here's the error, and you call it as a function, and it winds the call stack further. It doesn't unwind. And inside of the handler function, which is what was just called, it determines what should be done about the number format error. And it does this by either unwinding or by saying, I'm going to use one of X, Y, or Z pre-made ways that we could recover from this. And what defines what X, Y, and Z are available at the time is the code that signals the error. So whenever I'm going to like write some code that might fail, there'll be a signal somewhere in it, but I'll wrap it in a block that specifies, here are 3 ways that I can recover if an error occurs. But the code right there never actually calls any of them. It's only called if something up on the call stack decides that we want to recover. And so the way that this works effectively is that you have code at the low level that detects an error and knows how to recover, but it doesn't know which strategy will be useful at any given time. So you might have like a log analyzer that will see log messages that have an invalid format. And it'll say, hey, I found an invalid format message. You can either ignore it and not put it in your aggregate. You can put some specific value in here, or you can try parsing again with a different format. But it doesn't know which one of those it's going to do. Instead, it just signals this error. And then up on the call stack, you might say, oh, well, I'm in a thing that's just scanning for errors. And if anything doesn't match this regex, I don't care about it. So I'm just going to throw it out. But at other times, you might want to be able to actually track those. So it just allows you to express an idea of separating recovery from decision making.
But how does this? So your library. So maybe you can explain how that works and how it interacts with existing flows of exceptions.
So the way that it works internally is that it uses dynamic variables to bind the handler functions and the restart functions. The restarts are the recovery methods, and handlers are called when you signal an error. Those are bound using dynamic variables. And then in order to unwind, whenever it needs to get to the restarts, or if you just decide to unwind as a part of your handler, it throws something that extends from java.lang.error, which doesn't extend from exception. The entire purpose of that class in the JVM is that it's not caught by sane code. There's an unfortunate amount of code that catches from throwable, but I found that the majority of that seems to be in framework type libraries that will call your code, and then that throwable catcher is basically just making sure that there's some kind of harness so that it doesn't kill its thread that's like starting jobs or whatever. So it usually doesn't end up being a problem. The only actual problem that I've seen with that interaction is that the great library flow, fmnoise flow, which is for handling errors as values, which is really good for data pipelining, that catches throwable as well. So farolero has an extension inside of it that will detect if you have flow on your class path. And if it does, it'll load an extension to say, don't catch the unwinding mechanism from farolero. But the idea, more or less, is that it gives you facilities, especially for I/O, in terms of it allows you to write I/O code that is more general because you don't have to bake your error handling strategy into your I/O code. So if you want to do like retries or something like that, you can express that without needing to tie how you decide whether or not to retry to making a request.
But how did you end up knowing about? Well, knowing is a bit condescending, I guess. Because you started with C++, and then you went into Java already, and then because usually not many people I speak with, at least, unless they have written some Common LISP, they don't know about condition systems or restart things. So how did you end up knowing this? And then did you write Common Lisp? Did you learn it or?
So I learned about conditions and restarts from Special, which is one of the Clojure libraries that implements conditions. It doesn't implement restarts. And that's why I was saying that not all the libraries are super good for trying to implement the whole idea. It's not that they're bad libraries. It's just that they don't implement the entire
complete
thing.
yeah.
Or they have problems with threads, which that's one of the biggest things with farolero that I was making sure doesn't break is you can use it transparently with reducers and all kinds of other thread mechanisms, even core async, as long as you're careful to not unwind past a parking take. It works fine with core async and all the other libraries like that. And the biggest thing with it is that it also has the debugger, which is the biggest thing that I think is missing from, that's the biggest individual thing that is missing from all of the other libraries, is when a condition is signaled that's an error rather than like a warning or something, if there isn't something that handles that type of condition on the stack, it will ask interactively from the developer to determine how to handle the situation, which gives you an opportunity to inspect your program as it's running, and it actually gives you a REPL that you can use from the context of where the error occurred to evaluate whatever forms you want before specifying which restart to use to continue the application.
Okay.
And then the way that this all connects to the larger Clojure ecosystem, because exceptions are a thing that is used in the Clojure ecosystem, is that the default debugger, instead of dropping in and asking the user for input, you can turn that on intentionally. But if you don't turn that on, any kind of error that is signaled that doesn't have a handler will be wrapped in an exinfo and thrown. So you, as a library developer, you're able to write code that uses farolero and not expose that to your users if you don't want to. You just expose exceptions. Or you can expose
so they
it.
don't even need to know that it is internally using this restart or condition mechanism. Okay.
Yep, exactly. And there's also a macro that I added, wrap exceptions, which just wraps a form. And if an exception gets thrown, it gets caught and then wrapped in a condition and signaled, which allows you to bind whatever kind of restarts you want and then potentially just throw it again if you want to, without losing any kind of context.
Okay. But how did you... Okay, I know that you were looking at special, but is it because of some production code? Is it because of some pain that you have seen in the production code using these? Or
I am a conference talk junkie. So a lot of times when I'm working, I'll like have conference talks on the background, and I'm pretty sure that there was a conference talk, or I know for a fact that there was a conference talk that talks about the general mechanism
there was
that's used, and they do it almost entirely with just dynamic variables and no library. It was a libraryless approach. I'm forgetting the name of the speaker.
Was it Chas Emmerich? I just have a feeling. Or maybe it was Chowser. It was Chris Hauser, actually, I think.
Yeah, I think it was. But yeah, so that clued me in onto the name.
I'm a junkie as well, by the way, so, no shame.
That's fair.
Yeah, it's okay.
So that clued me in on like the name conditions and restarts so that I could search for it, and that's how I found special. And since then, I have programmed a little bit in Common Lisp. I don't like it as much as I like Clojure, by a long shot. But it is a good language. And there are still some things to be learned, even though most of it definitely feels like it hasn't been updated since 2002. Like the fact that there's still no like standardized mechanism for threads. There's some libraries that allow you to like write portable threaded code, but it's not a piece of the language really.
Nice.
But I programmed in it some, and that's what clued me in that special wasn't quite getting all the way to the dream.
So special wasn't that special.
Special was special because it put me on the right path.
Nice.
And I have some plans for getting nREPL integration with farolero as well, so that way the normal REPL in Emacs and whatever other application you have will be able to use like the normal REPL flow whenever a debugger is currently active. That debugger, by the way, is the other place that I've used refs, because there's a very interesting problem that doesn't come up in Common Lisp because of this lack of a standardization of threading. And that is, how do you handle it when multiple threads error at the same time? And because there's only one standard out, there's only one standard in, you have to synchronize access to that resource to the programmer. But you have to do it in such a way that the programmer isn't stuck handling one error when others have occurred, because you should be able to say, I'm going to handle this error later, I'm going to go handle this other one first. And the ability to swap between them has led me to write a quite complex piece of code that's using like raw Java objects as locks, using the locking macro in Clojure core, along with I think I'm using some standard queues in there, but I'm not entirely sure. And I'm using refs in order to wrap them up. So the whole thing is pretty complex. I'm happy that I don't have to write it that many times, because it's just once and it's in there. I'm going to have to write it a second time when I get the nREPL integration, because I need to have an nREPL middleware that will do that. But it was quite a hairy piece of code, but I learned a lot working on it, and I'm very confident that it's working correctly now. So that was a very interesting piece of code to write, though.
Nice.
I don't think I've never seen any code with locking, the locking macro. So
yeah,
it's not usually found in the wild.
I have probably used it a lot more than your average Clojure developer. That's fair. I have a tendency to like, I like Clojure and I like the performance guarantees that it makes, but sometimes they're just not good enough. And so when I'm writing libraries especially, I never want to force my users into making performance decisions based on the code that I've written. So as much as I can, if I'm writing a library, I make everything as performant as I can possibly manage while still providing the same interface. Because that way I can prevent, like, I hate the idea of forcing my users into decisions. And so all of my libraries are based around that core idea. It's just there's no decisions made for you. Because I found that works really well with the Clojure ecosystem of, like, you get little libraries for everything, you get frameworks for almost nothing.
Work with Coffi, but I ended up doing some stuff in Java, and it's kind of awkward, like you say, with Clojure depths, and I haven't got to that bit yet. So maybe I'll just use Americano instead, because that sounds like
it's a different flavor of coffee. So
yeah, exactly.
It's
cold and black.
You're taking your Clojure and you're watering it down with a little bit of coffee.
Okay.
So, or watering it down.
Back to coffee. Yes.
Coffi. So Coffi is a foreign function interface library built on top of Project Panama, which was released in Incubator in a form that is, like, actually usable in Java 17. In Java 16, they had a decent bit of it available, but the API was very different and not as usable. But as a result, with Java 17 now, we have the ability to call into any C ABI native code that we want using Coffi. I want to note that Coffi isn't the only library available in this space. There's other libraries built on top of JNA and JNI and a couple of other technologies as well. And those libraries are good, but I like writing game engines. And in a game engine, you can't afford to spend a lot of time marshaling data back and forth. and you
Yeah.
can't spend a lot of time in overhead from needing to dispatch via JNA. So I needed as much performance as I could squeeze out of it. And so Coffee is built using Project Panama, which is the most performant way to access native code from the JVM.
Mm-hmm.
And it basically is just a straight wrapper around the functions and classes that they provide, along with convenience macros to allow you to easily define a way to marshal Clojure data back and forth to native, and provide facilities to call whatever functions you want, even like with callbacks that are just written as Clojure code, as if it was just Clojure functions.
So, go on. So I was going to say maybe we should, because like a good conference talk junkie, I watched all of the talks about Project Panama in the background. So I kind of like got all the different angles from the author, and great project actually. So maybe it would be worth having a quick chat around like what Project Panama is and what the goals were, because I think probably a lot of the audience doesn't know it, because it's we're kind of like, for the majority of Clojurians, we're stuck on Java 8 or Java 11, and like Java, as Java changes underneath, it's kind of like, well, do we need to bother? And I think Project Panama actually gives us a reason, if we're interested in these use cases, to really leap forward to Java 17, because it's a fucking huge deal in my opinion.
I think it usually, I think when you're writing Clojure, you're only interested in JVM, but not the language or not the API that much anymore, right? Because that's
sure.
Because you're just playing safe in the cushy area of Clojure world, and well, okay, I'll upgrade whenever I want to upgrade. You're already using Clojure, but this sounds a bit pretty interesting. So maybe, as Ray said, I think it'll be nice to explain what Project Panama is and what it is going to bring.
Yeah, so the entire idea behind Project Panama is that it is bringing easy access to dynamically link against native libraries without the need to write native or Java code to do that. With the old JNI method, you had to write C code that would actually handle all of the marshaling of the data between the JVM and whatever native library you're calling. So you had to write C code, and you also had to write Java interfaces that would wrap all of that. I think it was actually more than just interfaces too. But there's also the library JNA, which is available on the JVM, which allows you to do exactly what I just said about Project Panama, where you get to write wrappers for native code that doesn't need you to write native code in order to link against it. But the problem with JNA is that it does symbol lookup and other forms of lookup in a very inefficient manner, redoing work a lot of the time. So the actual overhead of calling back and forth through JNA ends up being very high. So one of the libraries that I use to benchmark Coffee is GLFW, which is a library that's used for native windowing across platforms. But one of the functions that it provides just gets time since the library was initialized as a double. And that's a very simple piece of native code. It does very, very little work. But if I were to call it with JNA, it takes around 300 nanoseconds, versus with Coffee, it takes about 30 to 40.
Oh, wow.
So the difference is ridiculous when you're calling a lot of native functions all the time. And since one of my primary use cases for this is writing an OpenGL game engine, I'm going to be calling OpenGL functions all the time because I'm trying to render my game at 30 or 120 or 160 frames a second. And every single frame, I'm going to be calling dozens or hundreds or even thousands of GL calls. So I can't afford to have that much overhead on every single call that I make to native land. And so Panama allows us to bypass all of that overhead and all of the work of writing native code. So that's what Panama is promising, is promising a way for us to interface with native libraries in a way that doesn't require massive amounts of work and that doesn't introduce massive amounts of overhead.
But so I'm obviously I have no fucking clue about all this stuff, so I'm gonna ask the dumbest question, as usual. So you said that you can also write callbacks in Clojure that
Yep.
is being called back. So if there is no marshalling and unmarshalling of the data, and then how are you consuming the data in the callback as a Clojure map or Clojure
Right.
whatever data structure?
It doesn't require marshalling, but Coffee provides ways to interact with both native buffers that are just full of native memory, and if you're being called as a callback, you're going to get either one of these native memory handles as an argument or a primitive. And those two cases, so if you're just like making a function to add two numbers together, everything's primitives. And even though Clojure does boxing, Coffee does work to unbox everything, which takes runtime code generation. By the way, I do runtime bytecode generation using Inson, which is a fantastic Clojure library for runtime bytecode generation, and I use that in order to make sure that all of the types line up with what the JVM expects. But you get handle the native memory and primitives. But Coffee also provides convenience wrappers for everything that ends up being kind of the default way that you deal with things, where you can specify types using a syntax kind of similar to Mali. And the data description that you give, the data type description that you give, tells Coffee how to serialize and deserialize that from these memory handles. So you can write Clojure code that works with maps and use that as a callback that's supposed to take a struct. And Coffee will handle all of the marshalling that you need transparently.
And there is I think it's worth saying there's a kind of DSL in Project Panama as well for defining these native structs.
Yes.
So that's kind of like, I guess you're using that.
I'm not using that actually. I didn't find it to be very useful working with Clojure, because one of the primary concepts with it is the idea of a var handle, which is basically a way to quickly access data inside of a struct by basically like completing a path. So you say like it's in field A, which is an array, get index 2, and then get field B on that. Like, and you'd fill in pieces there. You'd say like, okay, well it's A sum index B, and then you'd fill in like the index that you're going to access. Like that's what the var handle idea is. And none of that is very like congruent with the way that you access data in Clojure. So I decided to just kind of ditch all of that and instead allow you to use the functions that I provide, which just allow you to easily access fields out of a piece of memory based on the type description, the Mali-like type description that you give Coffee. So you just call a serialize or deserialize function and pass it the handle and the type descriptor, and it gives you back whatever data you need. And so getting nested fields like that can be a little bit finicky if you want to be as performant as possible. But in the cases where you want to be as performant as possible, I'm perfectly comfortable with the concept of just handing the user one of these memory handles because it's an unwrapped Panama type and asking them to write the Panama code to interact with that. Because if they need that performance, then they shouldn't be using my custom marshalling because it's using multi-methods, which are fast. But if you're trying to be so fast as to not unmarshal data, you probably don't want to be using them anyway. That said, though, I've put in a lot of work into the macros and the other stuff in order to make sure that if you write a function that doesn't need any of that multi-method dispatch, that doesn't need any of the marshalling and unmarshalling, Coffee adds zero overhead. So there's no function call dispatch overhead for like anything in the library if you're not actually using any of it. So if you have like something that only takes primitives and returns primitives, there's just nothing that happens at all except for a cast. If you're dealing with something that takes and returns these memory handles, it doesn't go through any of this dispatch at all. So you're able to handle all of the underlying structures if you want, but it also provides facilities to make it so that calling native code is like calling Clojure code. And that's how I've wrapped libraries when I've been using Coffee myself, is to write code that results in what looks like a Clojure library, but is actually running native code.
So obviously the game engines are one of the primary use cases where near zero cost interaction with the native code is required. So where else do you think this is going to be useful? I mean, that means that you can use any native libraries, like any C code can be used just via Coffee?
What I've been thinking about doing is, for any kind of application that I write that has like some performance critical piece, it makes it a very easy, the existence of Coffee makes it a very easy choice for me to then go and write that performance critical piece of code in Rust and then wrap it in Clojure and then never have to worry about ownership again.
Yeah.
I think it's fair to say as well that the Project Panama people, I mean, and you have to wonder, like, what's the driver here? And the driver isn't games, actually, although obviously we're benefiting from that. The driver is talking to things like TensorFlow, because they give you a C API. And that's the thing that they're really concerned about in the Java world, is making Java play nicely with these kind of like low-level ML frameworks.
Or like the bullet physics for robotics or other things like that as well. Yeah. So
because I think until there is, as you said, with JNA native access and native interface, I mean, there is some sort of interaction with the native stuff, but there has always been like either you completely write the whole shit in Java and then make it available as a library. There is never easy reusability of the existing code bases which are in C, C++, or the native code available. That's not possible so far. But I think the idea that you say is pretty interesting for me as well, because I've been dabbling with Rust a little bit, and I think it makes sense that you can just fall back to, if that is the expression, that you can just switch to Rust and then build the whole thing, make it really fast, and then just use Coffee as a low cost or almost no cost FFI into that one. It's super cool, actually. Nice.
Yeah, and that means that, you've got kind of all these low-level performance wins, but you've got a nice high-level expression language like Clojure. So
exactly. And that's the same draw that like Python has in the ML world, is that it's a nice high-level language to interact with all the low-level C stuff. And we just get to also do that in Clojure without needing to use like libpython CLJ in order to call Python to call TensorFlow or anything like that.
Fun stuff.
There are other Clojure libraries that have kind of similar goals, and one of the good ones is I had the name in my head just a second ago.
dtype next, I think.
Yep, dtype next. That's it. Yep. So that's also a very good library. The difference that I've noticed between the library that I've written and a couple of the other ones is that my library is focused on usability from the Clojure side a little bit more than some of the other ones are. Not to say that they're difficult to use necessarily, but that there's more convenience features for users in Coffee, and that they're designed in such a way as to not introduce a lot of overhead. And my experience with dtype next is that it seems really good for like array programming, kind of in the same vein as like APL or something. Where all of the array stuff stays in native memory and never comes over into Clojure land. And you can do that stuff in Coffee. It will be less convenient than in dtype next. They're not necessarily incompatible as libraries, though. I believe that at least on JDK 16 and probably soon JDK 17, they'll use Panama as the backend for dtype next as well. Which means that once dtype next gets updated to Java 17, its performance will probably be pretty similar to Coffee. But again, the focus is a little bit different because dtype next is all about keeping like these big native memory slabs and operating on them from Clojure, versus coffi, which is focused on either just providing you access to all the handles that Panama does, or giving you access to call it like it's Clojure code. And the other difference there is that dtype next targets multiple Java versions, which means it targets multiple FFI backends. And that means it provides a different interface, which means they have a harder time providing Panama as like a key central feature. And coffi, I think of coffi being hosted on Panama kind of the same way that I think about Clojure being hosted on Java. Where it's not just an implementation detail, it's part of the core interface that's being provided.
Nice. So before we go into other, less important things, so Emacs or some other shit?
We've already done that one.
Not
We're
for
not going to do
Lojban.
2 fucking bites at this one.
Not for Lojban. I'm talking about other stuff.
Okay.
So
I have 3 different Emacs configs. One of them is entirely custom.
You win.
In org mode.
Moving on. we don't need.
BJ's been out Emacsed here.
That's it. You win.
It's Emacs to the max.
Yes.
Is one of them spelled EMAX?
Let's go through each of them one by one, line by line.
God, yeah.
Why 3 though?
So one of them is for work. It's like my old SpaceMax config that I was working with for a while. It started to get too slow, so I'm working on a Doom config. And that's what I'm using on my personal machine. And then the third one is like an experiment, me trying to figure out why the hell someone would do literate programming. And it's still unclear after having written a lot of code.
But it's I mean, I did try, obviously.
I keep on wanting to like literate programming. It's just very hard to like.
I think I did try Doom.
I think the whole notebook
SpaceMax.
world is all built on that, isn't it?
Pretty much.
Yeah.
Come on, it's not near. That's exactly what it is.
But I don't think people are using notebooks to do like literate programming. I mean, it's just like cells of code.
Well, the idea is to make you describe the paper and do the programming in the middle of the paper.
Yeah, fair enough. Yeah.
That's true, and there are some good examples of like literate programming. For example, there's the physically based rendering book. Is a book that's written entirely as a literal program.
Yeah, but isn't there a paper or something on Clojure code base as literate programming? Yeah. That was a long time ago.
Ferret is a Lisp that's designed for embedded programming, and it's written in Clojure as a literate program.
Yeah.
And it's an interesting code base for sure.
But I think that the main thing that I found with literate programming is that the code base, or maybe I've been in that tells more about my coding skills rather than literate programming. But anyway, I think code is not linear, right? Because it's very difficult to linearize the code because there are modules, there are interdependencies, and because literate programming assumes that you can read it like a book from end to end, like a story.
Yeah,
which is
like COBOL.
Exactly. Which is not really possible
I tried solving
anymore.
that in my own. I tried solving that in my own projects by not sticking to the there is one document rule.
Yeah.
And instead splitting up and having modules be their own books, and even splitting it up to try and make things so that instead of it's like the whole program is one text that you read, it's like each piece of the program is one text, and then there's a final text that pulls everything together and basically is only cross-references.
Yeah.
Even with that, I still couldn't really find it as something that was useful to my programming, and that might just be because I have like abused myself into reading code more clearly than I read English.
Yeah.
That might just be what it is, but
you speak Lojban. I mean, come on.
Exactly.
You're a difficult, like a bit of anecdote, I think.
Yeah.
But I think it never. I was intrigued by the idea, and I like the like it in theory, being able to express that, this is the idea and this is how it looks like code, and then using arg mode to tangle the code into different files, and it's fun to think about as a theoretical experiment. But I don't think was it Knuth? Yeah, I think it was from
Yep, it
him,
was
right?
Knuth.
So yeah, and I never felt like, well, maybe in Clojure it is still possible because you can just use declare and then make it linear more or less. But rest of the code bases, they're never linear, they're always dependencies, and you just give up, like, oh fuck it, I'm not gonna spend like explaining Lord of the Rings level text to print a plus b. Like, okay, no way, no, moving on.
Right. And
Well, I think if you think about threading pipelines, like the thread macro is a tricky one. There was another conference talk about that, actually, about how you can put some macros around the thread macros to make it more literate and more maybe you remember that one, Joshua. I don't remember.
I do.
I know the talk, but I can't remember the bloody author or the framework or the library now. But I'll look that one up for the show notes.
That's a call to our audience. Please tweet at us.
Wasn't that one also the talk that ended up introducing as arrow, con arrow, whatever?
Could have been
several bang something like that ridiculous thing.
Possibly. I don't want to cast aspersions though. As thread aspersions.
Anyway,
yeah. But what I was going to say was that that is the problem with like literate programming.
Thread first, thread last, backwards, question mark, as arrow, con arrow, bang is the name of the library.
I like that kind of names. It's what you see is what you get, or what you read is what you get.
Yeah. So this is from a different talk. This is from every Clojure talk ever. Which is a different one from the threading one you're talking about.
Yeah.
But
okay.
I think I've seen the threading one as well. My favorite like abstraction to throw in with threading macros though is just a when pred and if pred, where it takes the value as the first argument, a predicate as the second argument, and then a third argument as a function to run if it returned true. And I've not found that in any of the utility libraries like that I've looked at, whether it was like based on threading or not. And I don't know why I've never found it in one, but it's very useful. I use it in my code all the time.
Nice. Can you say that again? I must have been slightly screwed for that one.
When pred takes 3 arguments. First argument is the value because you're using it inside of a thread macro. The second argument is a predicate, and if it returns true, you call the third predicate on the value before returning it. And if it returns false, then you just return the value without changing it.
Right.
And then if pred is the same thing, except there's an else.
There's a branch. Yeah.
Function.
Okay. Yeah.
But isn't it?
Because that's the only thing about like when in Clojure is always a bit odd to me is that by the else is actually nil.
Yeah, that's true. Which makes it a little inconvenient inside of threading macros.
Yeah.
Yeah. So what else? So we talked about the coffi as well as the condition system and then discard thing and a small build library as well. So I'm really not surprised, but I'm really amazed by how much knowledge you accumulated within this time. And when I was 23, I was trying to figure out how to make a VB button do something. That's my achievement, back in the day. So I'm really amazed by how many things that you dug into, and then how much knowledge you acquired, and including all the way from C++ until Common LISP thing. And I'm curious about your ideas of what sucks in Clojure, because you wrote C++ and you're now providing a way to reach into the native world. When would you say, well, this is not something that I would do in Clojure? Or when would you say, well, this is pretty shit in Clojure?
This is going to sound kind of funny considering the library that I just was talking about. Error handling. Error handling is awful in Clojure.
Yeah.
It is terrible. there are good libraries that you can pull in to make it better. But the fact that we don't have a default error handling strategy besides throwing exceptions, which maybe I have to make the argument that throwing exceptions is a terrible way to do error handling, but I think that that's the case, is that it's not a good way to do error handling. And so in Disclojure, this is the first like major public library that I made. I had no idea how to do error handling, and as a result, that code base does not throw an exception except for an illegal argument exception when you try to start up the thread for the first time. That is the only exception that occurs in the entire code base. The only other way that I interact with exceptions is trying to catch exceptions that are thrown by user code.
Yeah.
There isn't really any other error mechanism inside of it. And it's because error handling in Clojure is terrible, because you basically have either nil punning, which is okay if you want to like ignore some kind of data error, but it's terrible if you want to understand what's happening in your program. Throwing an exception is great and all for getting a log of like a stack trace if something actually went wrong, but I treat it like a panic in Rust. You throw an exception when you can't recover. And so all that's useful is a stack trace, and you can't really get anything else. Using errors as values with flow is really nice, and it works well for data pipelines. But when you're not writing a data pipeline, which, considering how many IO libraries I've talked about, that I've written, like I'm not always doing data pipelines. So I'm stuck with basically no good facility except for the one that I wrote. And even that one could be better. And part of the way that it could be better is if it was integrated into the
language itself,
the
core,
the library ecosystem. Not necessarily the language itself, but like the library ecosystem. If people were using it, it would be a more pleasant experience to use. But that's kind of like a chicken and egg problem.
But this is.
I think that's what ended up being the thing of Chris Hauser in the end. He was saying that you it's like putting it into the libraries, putting it into things. It's just impossible. So he has some ideas about how you can handle, problems.
But
so
it is
a kind of like almost a kind of hands up in the air, kind of
that kind of error handling with just the dynamic variables and providing that as a part of your public interface is part of what I provide as a instruction for library authors in the README of farolero. I give utilities for library authors in order to make things that can integrate with the ecosystem. And I think it's mostly just that either the library isn't old enough yet, or people haven't tried to use it, or maybe it sucks and I'm the only one who doesn't know.
No, we're getting the word out here, Joshua. So you expect a huge uptick in adoption in the next month or two.
That would be pretty cool.
2022.
It is currently my most starred repository, so we'll see.
Good.
We'll see how that goes.
There's a bit of code, like there's a bit of pornography going on there. Everyone is kind of like loving the idea of watching it, but not quite using it.
Yeah.
But isn't it something like the philosophy of the language itself, right? I mean, in Rust, you're always using a result. You're always like kind of it's like a idiomatic way of doing things, and then in Clojure being a dynamic language, and I don't think anybody cares about. I've seen so much of Clojure code where it only deals about happy path. Nobody cares about exceptions because it's not there. Obviously, it's not forcing you, and nobody thinks about like the conditions or restarts, or because happy path is working and fuck it, I'm done. And then it's when people are using it, when it blows up, they know what to do. Like that's it's more.
The garbage in, garbage out philosophy. Garbage in, garbage out philosophy is fine. I actually don't mind it. That's how Disclojure works. I have everything internally spec'd, and if you turn on instrumentation, everything will be fine unless you fucked up somewhere putting something into one of the functions that wasn't supposed to be there, and then everything will blow up. And I don't have a problem with that. I consider that just the documentation is the specs. You can look at them. That tells you what you can put in there. And if you turn on instrumentation, you'll see what's going wrong. I don't have a problem inherently with the garbage in, garbage out. What I have a problem with is when things that are errors that are part of the happy path, because those exist. There are happy path things that are errors.
Yeah.
And Clojure doesn't have a good way to handle those. And because like everything from honestly, even baked into the language is what I feel about this, because exinfo is a terrible mechanism for signaling errors, because of the fact that it requires every single person who catches one to check to see if it's actually the exinfo that they think it is. And if it is, then do something about it, otherwise rethrow it. And if they're not doing that, it's because they're not considering what happens when someone else's code is running inside that context. And people don't think, you're right, people don't think about errors that much, but I think that's just an unfortunate aspect of the escape from Java, honestly.
Yeah.
Because in Java, we spend like half of our code by lines of
like
code inside of a catch block. Like everything is a catch block.
Finally catch.
Exactly.
Because that's the other thing, you know.
And if people are escaping from Java, part of what they're escaping from is that. And I can appreciate that. And I can appreciate that it is nice to only worry about the happy path. But it just leaves us in a situation where it's less than optimal when you have to actually, handle an error.
Yeah. That's a fair point. Yeah. So I think
one kind of like saving grace from this, though, and it's not the perfect retort, but the fact that exinfo is now data is a lot better than like raw exceptions prior to 1.9, I think it was.
Yeah.
So I think there is progress being made there, but you're right. I mean, there's still a lot of work to be done for sure.
Slingshot, Try Plus, there are libraries in that space that help out, and they do help out, and they're good. But I don't think that they really solve the core issue necessarily.
Yeah.
And I can't say that I necessarily know what the core issue is. The reason that I wrote Farolero in the first place was to see if having that facility would help me realize what the core issue is. Because as I experienced when I first heard about Clojure in AP Computer Science, all of the things that you can do in Clojure just seemed like weird things that someone else would want to do, but I have no reason to. Because I was in the Java mindset.
Yeah.
And working with Clojure before working with Farolero, I have been in the nil punning and happy path mindset. And I figured if error handling feels bad and I don't know what the core issue is, maybe if I try this thing that someone else thinks is the solution to the core problem, maybe I can start to understand what I think the core problem actually is. And so I wrote Farolero so that I can try that. And in the last 6 months, I've gotten to use it both in production at work and on my personal projects. And I think now I'm at the point where I have enough experience using it that I'm pretty comfortable with the facilities that it provides. And I'm hoping that in the next 3 or 4 years, I can actually finally figure out what the core problem is with error handling in Clojure. And then maybe I can write a library after that will actually solve the problem. But we'll see.
But I think
it's good to have ambitions. Yeah, on that bombshell.
I think before wow, we are almost 1.5 hours, and I think we can keep talking forever. But I'd like to mention just it's really the mindset problem, right? It's not, as you said, like we're used to so much in writing happy path in Clojure, and if you switch to a language where it forces you to write, I mean, I write Rust with unwraps everywhere. I'm like, I don't give a fuck. I'm just going to unwrap everything and then continue. Which is obviously not the way, but it's actually putting it front and center in front of me, like I'm doing some shitty thing here, instead of thinking about
and you can
the code.
grep for unwrap and see where
exactly
your problems
where
are.
Yeah,
you can't do that.
He just grep -v unwrap.
Yeah.
So know that I think it's more like a mindset thing, but which is something similar to writing tests, right? I mean, the more time you spend thinking about the code, and Clojure gives you this easy
I'm
way
probably going to be
to
unpopular if I start talking about tests. Oh no.
Yeah, but that is the thing with I mean, I've seen this in Python as well. I mean, all the libraries, they just do like one thing and then they're happy. Fuck it, no design, no errors thrown, nowhere.
Mhm.
You never know what kind of shit is gonna blow up, and down the lane, like it's 7 transitive dependencies later. So which is
Mhm.
something worries me. But hey, it's been working for Clojure for 10 years, more than 10 years, so maybe there is something, and maybe people will pick up, rethinking to make code more robust in that sense. But
Yeah. I mean, the fact that it's been going so well for so long tells me that even if it is like a fundamental problem that we don't know how to handle errors, it clearly isn't getting in the way of us actually solving problems. So it's not necessarily a huge deal. It's just one that I think would be beneficial to everyone in the Clojure community if we can.
Totally.
I think it's a rough edge, and it's okay to say
solved.
that there are rough edges. I think that's and
Yeah.
and even if it wasn't a rough edge as such, that innovations and improvements can always be welcomed.
Yeah.
Like you say, especially in the user space where you're not asking for the core team to change anything really. I mean, I guess that would be nice, once you've kind of got down to the core bottom of it all, and you can sort of say, look, this is the fundamental challenge. But on the other hand, like you say, if you're learning from Common Lisp, then that's already a great place to start.
Yeah.
And it's a close cousin.
Until you want an immutable data structure to work with a library, it's a good start.
Yeah.
There are libraries that give you immutable data structures, but they don't work with the other libraries, so you have to write everything yourself. So good luck with that. Common Lisp is a good place to start. It's a good language, but the library
I just mean as a source of inspiration,
rather
than a sort of. I'm not trying to advocate for Common Lisp as a language on the Clojure podcast that we've been going for a while.
Yeah.
No, we came for immutability and we stayed for the error handling. No, hang on.
The other way around. Nice.
Yeah.
Awesome. I think wow. Maybe that's it. Before we wrap up, maybe since we already since I already asked you like what is wrong with Clojure, well, not in that strong sense, but what do you like
exactly
about
how
Clojure?
You asked it,
Yeah, sure. At this point, I don't care anymore. I'm like, we're too popular to be awkward anymore. So what do you like about Clojure? And did you try Clojure script as well, or mostly you're dabbling, in the Clojure side, JVM side?
Yeah. So I like the fact that Clojure gets out of my way and I can actually like think about my problem space. I have like done more whiteboarding with Clojure than I have with any other language because the whiteboarding that I do isn't a UML diagram because I don't have to think about all of that.
Yeah.
I like not being stuck in that. So instead I get to actually think about, the problem space. How do I connect the pieces together? How do I decompose things into a set of reusable parts and then put them back together?
Yeah.
And that's why I like Clojure. And then what was the second question?
Clojure script? Like, did you try,
Clojure
script or other flavors of Clojure, as they say?
Yeah, so I have used Clojure CLR on the Unity project Godot. Godot. On Arcadia.
Yeah,
Arcadia. I actually did like a game jam game with Ramsey Nasser and that was pretty fun. I did like an input system for one of the games that they did. It wasn't that much code, but it was fun to get my feet wet in that. I've tried Clojure CLR for a couple of other things as well, and I've used Clojure script. Farolero works on Clojure script.
Oh, nice.
And because it's all CLJC, and I had to do some shenanigans. The debugger doesn't work in Clojure script because there's no
Yeah.
standard in or standard out, but
Mm.
the rest of it does.
Mm.
And there's ways to connect the debugger if you want to. I've used ClojureScript for mobile development, and I've
Mhm.
used it for some website development. I don't have anything that's like public with it now. I
Yeah.
really liked using Expo for the
Mhm.
mobile development with it. And last time I used it, even with Figwheel, like Figwheel main and Shadow CLJS, it still could use a little bit of work on the reloadability aspect compared to JVM Clojure. At least that was my experience.
Yeah.
It's really good, but it could be better.
Yeah.
Put it that way.
Yeah. Yeah.
I don't use it for anything significant now, although I have been thinking about starting a blog to try and talk about the implementation decisions and stuff in the libraries that I make and other stuff like that in order to try and talk through those thoughts. Even like I'm working on a compiler to compile Clojure code to GLSL in order to run Clojure on the GPU.
Okay.
And like that kind of thing would be something that would be useful to like have like a blog or something. And I've been thinking about writing that in ClojureScript.
I think it makes
but
sense. I mean,
I
like,
haven't gotten around to it just yet.
I think it's really nice to have that written down on the internet because it's much more searchable, right? I mean, obviously, our podcast is the thing in the Clojure world, as you noticed already. If we are not talking about it, then it doesn't exist. That's the level that we have.
But you can expect plenty of calls from cheap imitations, but this is the main thing.
Yeah.
But I think it'll be really nice to I know writing a blog, telling other people writing a blog is pretty easy, so I'm just gonna do that. And but because all these things, and we can only condense so much in 90 minutes, right? So there you can point to the resources, explain the your thinking behind it, because you have amazing ideas. You're working on really nice libraries, and moving Clojure to the next generation, like bringing closer to Java 17 and all that stuff. So I would really urge you to write the blog post, probably in English, not in Lojban.
Yeah, English is far more likely. Despite the fact that most Lojbanists are programmers, there still isn't that much vocabulary for talking about programming yet.
Okay.
I think the other thing to do, I think that some people are doing, I mean, you can take this any way you want, but I mean, you're a great speaker and very fluid, in English as well, by the looks of things. So it's like, I think people do things like on Twitch or on YouTube, streaming, and that could be something that you could do to kind of get the sort of the people who want to watch these videos on the side, like us, so you can get a bit more content out that way. Obviously, the nice thing about things like podcasts is that you can kind of like listen to them on the go. And I think if you have a blog, then I guess people can read it on the go as well, by text to speech type stuff. But I think it's worth considering other media strategies as well, because
TikTok,
definitely, I think for sort of the stuff that you're doing, having a kind of like interactive explanation of these things would be really interesting.
I mean, I'm not on TikTok, but I would say just make a TikTok video like why coffee, then this, and
do a dance while you're doing it. Yeah.
Yes.
I'm considering the average age of Clojure developers. I'm more the exception than the rule. I don't think I'll get that much viewership.
That's true, but I think this is the beautiful part. Like we're very happy to see that people talking about, oh, I started with Java 7. I'm like, wow, that's
I know
that's amazing to hear. And it's amazing to see people like you who are so young and getting into this one, and also bringing so much of knowledge within such a short amount of time, which is really admirable. And I think you are probably inspiring way more TikTok generation than old age crappy people like me who never installed TikTok. I don't even know what the fuck people do on that shit. But anyway,
Jesus.
Well, but that's the thing, right? This is the time, because this is the the ideas need to evolve. Idea needs to get into the next things. Otherwise, we are um, when just to conclude, when you said that people are not thinking that the error handling is a big deal, because we are so used to our ways this has been something in the Clojure thing since we started talking about Clojure, because I've been dabbling with Clojure for almost like maybe 10 years now. So the beginner experience has never been a thing, because all the people who are getting into Clojure has always been like people who have written 20 years of code coming here. And then if I see a stack trace, I know exactly where to look, because I've been conditioned like a Pavlov's dog to ignore all the CLJRT shit now. And that means I can't see the problem.
Yep.
I'm too blind for this thing. I'm too old for this thing. But that's what
he's been basically good through the 10 years of Java himself, so it's kind of
yeah. I had 8 years
started
of Java.
At 9. That's the problem. So he's kind of like old before his time.
Exactly.
Yeah, I had 8 years of Java before I started with Clojure. I was never puzzled by the stack traces. They made sense to me.
Of course,
that's probably Lojban. You shouldn't have learned that language.
I learned Lojban like 2 years ago in 2018.
Yeah.
Like October of 2018 is when I started. I started on Clojure well before that.
Yeah. But in any case, I mean, I love the the ideas that you're bringing in, and then Clojure is not this old ass people complaining and grumpy old folks sitting remotely somewhere writing like hermits.
Well, the funny thing is that actually the sort of the grumpy view of things is, shouldn't we be handling errors better? It's quite nice to have a young person basically saying to all these old folks, "Hey, old folks, why aren't you handling errors better?"
Yeah.
And I know I'm gonna get scorched for this, but I remember, one of the Clojure core teams saying that Clojure is optimized for correct programs, and I nearly spat my coffee out. It's like, what the fuck? So that's intolerable. So you're absolutely right, Joshua.
Yeah, I'm sorry. If we're looking for proofs of correctness, we should be looking at Idris, not Clojure. We're writing in Clojure because we want to get something done, not because we want to prove it's correct.
Exactly. Yeah. It's done. It's not correct, but it is done.
Well, I can't prove that it's correct.
Yeah. So it behaves like a correct program.
Yeah, but I think we're going back to philosophy now, because nothing can be provably correct. But
well, I think that's kind of the entire point of Idris, is that the type system is a prover that proves that you're not accessing things out of bounds, et cetera, et cetera.
Yeah.
So,
well, I mean, that proves certain. That proves a certain thing, but it doesn't prove. It doesn't prove correctness of your idea.
It doesn't prove that it doesn't prove that your program is a correct implementation of the.
Yeah, exactly. Yeah,
exactly. That's true.
Yeah.
Things like cock and
I think GPT-5 might be the only way that we can do that.
Yeah.
We look forward to the library that you're going to build for that one.
GPT-5, prove your requirements are correct to the program. Maybe I can write a library for that. Sure.
But I agree with Vijay. I think it's really good to have like young people like yourself, the under 30 crew, let's say, well under 30, to be like, it's not just the next generation, it's the next generation below the next generation. Getting stuck into dynamic programming and Clojure, and also doing all the things that are awkward, like the foreign function interfaces and the refs and the vars and all this kind of stuff, the error handling. You're doing the awkward stuff, which is really great. You're not just kind of floating along and taking the advantages. You're actually saying, oh, there are some fun parts to this, to the edge of these environments which aren't well explored. So I think it's really good.
Pretty much every time that I've published something like publicly, it's been because I ran into a very jagged edge of whatever system I was working in. Farolero, Coffi, Clojure, all of those are examples of, it was a jagged edge at the edge of Clojure. So I figured maybe I can provide something to smooth it out a bit. So Yeah, it's
Well,
definitely
no one over
thinking.
40 has ever heard of Discord anyway, so that's it.
Well, they're trying to fix that now. They're trying to market to everybody. I don't know how well that's working, but
Yeah.
Not me. It doesn't work for me.
We have a deafened Discord actually, but
that's what I heard.
refuses to go onto it.
I do have the app. I joined. I mean, there are so many fucking chat apps now. I'm kind of done with this thing anyway.
Yep, there's a lot of them.
Yeah, totally. Anyway, on that bombshell, and hey Joshua, thanks again for coming on and talking about all these things. And as Ray mentioned, finding fun in the things that are not that mainstream. It's not yet another web application, yet another web framework or some other thing, but you're doing awesome work, and I love the way that you're thinking about the errors and conditional stuff. I'm going to check them out as well, because it gave me some nice fuzzy feeling of Common Lisp again a long time ago. So hey, thanks again. And I think you should come back again when you're gonna solve the core problem and build your next library. Then we should have more discussions soon, and maybe about Rust as well.
Yeah, it'd be really cool. Thank you.
Awesome.
All right. Thanks,
Thank
Joshua.
you. And for the listeners, if most probably this episode you'll be listening to this in the new year. So we wish you a very happy new year. It seems like we are reliving 2020. Which is a good thing. That means we are not aging another year. We could just get stuck in 1 year, and then we're not getting older, which is good. But anyway, yeah, exactly. 2021 has been like foggy, but I hope everyone who is listening to this is happy and healthy, and happy holidays. And we'll keep doing this fun stuff. That's it from us. Thank you for listening to this episode of DefN. And the awesome vegetarian music or the track is Melon Hamburger by Pizzeri. And the show's audio is mixed by Wouter Dullert. I'm pretty sure I butchered his name. Maybe you should insert your own name here, Dullert.
Wouter.
If you'd like to support us, please do check out our Patreon page. And you can show your appreciation to all the hard work or the lack of hard work that we're doing. And you can also catch up with either Ray, with me, for some unexplainable reason. You want to interact with us, then do check us out on Slack, Clojurian Slack or Clojureverse, or on Zulip, or just at us at DefN Podcast on Twitter. Enjoy your day and see you in the next episode.
Hello again, dear listeners. This is a small interruption on your way to enjoy other high-quality Clojure podcasts, with a reminder about the Discord experiment that I mentioned before the show started. In case you missed it, we're launching an experiment on Discord to have a call-in style follow-up to the episode. You'll be able to hop into the call as well as text questions and responses. Our guest has kindly agreed to be part of the experiment, and we'll add details into the show notes, and you can follow mine or VJ's or the DefN Podcast Twitter account for more details. Thanks again for listening.